Welcome to everyone. My Shifty Muthukumar, Assistant Professor, Punganadu College of Engineering and Technology. So, in this lecture, I am going to deliver sine wave generator under the linear integrated circuits. With the help of operational amplifiers, we are going to design the sine wave generator circuits. So, sine wave generators. So, this sine wave is one of the fundamental waveform for all the purpose. So, variety of circuits are designed to generate the sine wave signals. The conventional method, we are using the RC phase shift network to generate the sine wave waveforms. So recently we are using operation amplifier to use for the oscillator to generate the sine waves. So op-amps are used as oscillators to generate the sine waves. So oscillator is a circuit that generates the output voltage without any input signal. So they are used as signal sources in all sorts of applications. So there is no need for the input, it automatically generates the output. So they employ the concept of positive feedback, where a small portion of the output is fed back to the input in a way that causes it to reinforce itself, and the certain and the continuous output will be obtained. So here we are giving the small amount of positive feedback. Output is given to the feedback. It is a positive feedback. They are used in radio, TV, computer, and communication purpose. So sine wave is a fundamental waveform. So we are going to generate with the help of many circuits. So conventional method of RC phase shift network. So presently we are using the operational amplifier as a sine wave generator. So it is used as oscillator to generate the sine waveform. So oscillator means so generate the output voltage without any input. Here positive feedback we are going to employ. Small portion of the output is feedback to the input. So finally sustained output will be, continuous output will be obtained. So first we are going to discuss about RC phase shift oscillator. So RC phase shift oscillator is a sinusoidal oscillator used to produce a sine wave oscillations. So applications of RC phase shift oscillator. So it is used as local oscillator for synchronous receivers, musical instruments, study purposes. So synchronous receivers, musical instruments, study purposes, we are using the RC phase shift oscillator. The main part of the RC phase shift oscillator is an op-amp inverting amplifier. So here using the inverting amplifier with its output fed back to its input using a regenerative feedback RC filter network. So two important parts are there. One is operational amplifier in inverting mode. So another one is regenerative feedback RC filter network. So combination of RC filter produces the phase shift of 180 degree. By varying the capacitor, the frequency of oscillation can be varied. So in the RC network, so varying the capacitance value, the frequency of the oscillation can be varied. The feedback RC network has a phase shift of 60 degree each. So here we are using the 3 RC network. So total phase difference is equal to 180 degree. So individual RC network produces 60 degree phase difference. So we are using the 3 RC phase networks. So total phase shift is equal to 180 degree. So op-amp is used in inverting mode and its output is given to the feedback network, whose output drives the amplifier. Identical RC network can be used in the feedback section to avoid the internal model oscillations. So RC network should be identical. So this is the circuit diagram of RC phase shift oscillator. So this is operational amplifier. It is working in the inverting mode of operation. So we are giving the positive feedback to the inverting terminal. So the help of resistance through R1. So RF is called the feedback resistance. So this is the RC network. So capacitance and the RC. R and C provides the feedback RC network. So we are using the 3 RC networks. So every RC network produces 60 degree phase difference. So totally, so phase difference is equal to 180 degree phase difference. So this 180 degree phase difference is given to the operation amplifier. It also provide the phase difference. So this is the feedback voltage. So we are giving the negative voltage. So negative periods. Short swing negative cycle is the feedback voltage. So this is the output voltage of the operation amplifier. So this is a sinusoidal waveform. So frequency oscillation. So F is equal to 1 by 2 pi RC into root 6. So this is the frequency oscillation. By adjusting the value of R and C, the frequency of oscillation of the oscillator will be varied. So this is the operational amplifier based RC phase shift oscillator. So produce the sine waveform at the output. This feedback network is to provide the feedback. RC network is to provide the feedback to the inverting terminal. So F is equal to frequency of oscillation. F is equal to 1 divided by 2 pi RC into root 6. So this is the frequency of oscillation. The above equation shows the expression for frequency oscillation. So at this frequency, beta value is equal to 1 divided by 1 minus 5 into root 6 square. So that's equal to 1 divided by minus 1 divided by 29. So minus 1 divided by 29. So this negative sign indicates phase shift of 180 degree. This negative sign indicates the phase shift 180 degree. So beta value is equal to 1 by 29. So to have the oscillations, its modulus of AB greater than or equal to 1. So to have the sustained oscillation, modulus of A beta is greater than 1. From this equation, modulus of A is equal to 1 by modulus of B greater than or equal to 1 divided by 29. So from this equation, modulus of A greater than 29. So gain of the amplifier should be greater than 29 to provide the oscillations. So formula for the oscillation, F equal to 1 by 2 pi RC into root 6. So C provides the change in operation. So the merits of RC phase shift oscillator. So it is a simple design. Since signal output in the audio frequency range, sine signal output in the audio frequency range. So simple design. So produce the sine wave. So sine signal output in the audio frequency range. So fixed frequency sinusoidal oscillator. So frequency will be fixed. So these are the merits of the RC phase shift oscillator. So next, demerits of the RC phase shift oscillator. The frequency stability is poor due to changes in the value of various component due to effect of temperature, aging, etc. So we are going to change the value of capacitance. So and the temperature also effect, and the aging factor is one of the factor to affect the stability of the frequency stability. To have a variable frequency as output, all the three sections R and C must be changed simultaneously. This is practically impossible. So we need to get the AC frequency value, means we need to change the R and C value simultaneously, but this is impractical. So these are the advantages and the disadvantages of RC phase shift oscillator. So next, I'm going to discuss another sine wave generator, that is Wien bridge oscillator. So this is the most popular type of oscillator. So used in audio and sub audio frequency range. There is a 20 to 20 kilohertz. The range of oscillator is 20 to 20 kilohertz. So this is simple in design, compact in size, and a remarkably stable. It is stable output frequency. So simple design, compact size, so output frequency is stable. Further, the output is relatively free from distortion and its frequency can be varied easily. So the maximum frequency output of a Wien bridge oscillator is only about 1 megahertz. So this is the maximum frequency deviation is equal to 1 megahertz. So Wien bridge oscillator is also called as Wheatstone bridge oscillators because the circuit is based on a frequency selective arm of the Wheatstone bridge circuit. So sometimes it is called Wheatstone bridge oscillator. The Wien bridge oscillator has a good stability at resonant frequency. So at resonant conditions, the Wien bridge oscillator provides the good stability, low distortion, and is very, very easy to tune, making it popular circuit as an audio frequency oscillator. So it is used in audio frequency oscillator. So this is also RC oscillator that uses RC type feedback network. RC, we are using the R and C as a feedback network. The basic difference between the Wien bridge oscillator and RC phase shift oscillator is in RC phase shift oscillator, the amplifier stage introduces 180-degree phase difference. The feedback network introduces 180-degree phase difference. So total phase difference is equal to 360-degree around the loop. So total phase difference is 360-degree around the loop. But in Wien bridge oscillator, non-inverting amplifier and hence does not provide any phase shift during the amplifier stage. So only 180-degree phase difference is given by the feedback network. So amplifier does not provide any shift because here we are using the non-inverting amplifier. So there is no shift in the output voltage. The Wien bridge oscillator uses the feedback circuit consists of series RC circuit connected with parallel RC. So series RC and the parallel RC circuit connected of the same component values producing the phase delay or phase advance circuit depending upon the frequency. So this is the Wien bridge based oscillator. So this is Wien bridge. So in the 4 arms, so arm 1 and 2, so R1 and C1 connector. So 3 and 4, R2 and C2 connected in parallel. So R3, R4 is connected in arm 2 and 1. So this output is given to the amplifier stage. So finally output getting the V0. So this is a Wien bridge oscillator. So now we are going to discuss the Wien bridge oscillator using operational amplifier. So this is the operational amplifier. So negative is connected to the resistor R1 and the feedback resistor is given connected between the non-inverting terminal, inverting terminal and pin number output terminal, pin number 6. So non-inverting terminal is connected to the feedback network. Here one parallel RC network is available, one series RC network is available. So this combination provides the feedback to the operational amplifier. So output is V0. The frequency oscillation F equal to 1 divided by 2 pi RC. This is the frequency of oscillation. So I'm going to conclude this session with a small recap. So the topic is sine wave generator. So it is one of the essential fundamental waveform. So variety of circuits are used to generate this wave. Here we are going to discuss basic conventional RC phase shift network and the operational amplifier based RC phase shift oscillator and a Wien bridge oscillator. So oscillator means it generates the output without any necessity of the input. So here we are giving the positive feedback. So portion of the output is given to the feedback. So user in radio, TV, computer and the communications. So RC network is to provide the phase shifter. Each RC circuit provides the 60-degree phase difference. Totally we are using 3 RC network. So total phase difference is 180 degree. So this is the circuit diagram. So the operational amplifier, this is in the inverting mode. One is grounded. So R1 is connected in the terminal to inverting terminal. So feedback also, output of the RC feedback network is given to the inverting terminal. So RF is the feedback resistance that is connected between inverting terminal and the output terminal. So capacitor C and the resistor R forms a RC network. Each RC network provides 60-degree phase difference. Totally we are using the 3 RC networks. So total phase difference is equal to 180 degree. So again, amplifier also provide 180 degree phase difference. So total phase difference around a path is equal to 360 degree. So F is equal to 1 by 2 pi RC into root 6. This is the frequency oscillation. By adjusting the value of C, so we are able to get the frequency of oscillation, different frequency of oscillation. So F is equal to 1 by 2 pi RC into root 6. So here the gain modulus of A greater than 29. So gain of the amplifier should be 29. So these are the merits. That is advantage, simple design, sine signal output in the audio frequency range, fixed frequency sinusoidal oscillator. These are the merits. Demerits means the frequency stability is poor because we are varying the R and C value to achieve the frequency oscillation. So also temperature affect the frequency stability. To have a variable frequency as output, all the three sections R, C must be simultaneously varied, but it is practically impossible. So Wayne bridge oscillator. So it is another type of oscillator. So the frequency range is 20 to 20 kilohertz. So Wayne bridge oscillator has a good stability as its resonant frequency. So it has a low distortion and is very easy to tune, making it a popular circuit. The difference between the RC phase shift oscillator and the Wayne bridge oscillator is in RC phase shift oscillator, we are using the amplifier in inverting mode, but in Wayne bridge oscillator, we are using the non-inverting amplifier. Therefore, the phase difference is only 180 degree by the feedback network. So this is a Wayne bridge based RC, Wayne bridge based Sinewave generator. So frequency sensitive arm. This is a frequency sensitive arms. So 4 arms here, so resistance and capacitor connected in series and parallel combinations. So this is the operational amplifier based Wayne bridge oscillator. So R1 is connected in to the inverting terminal, another end is grounded. So RF feedback resistance connected between the negative terminal and the sixth terminal. Here, one RC series network, one parallel RC series network are used to provide the feedback. So F equal to 1 by 2 pi RC. Thank you.